chord of contact, no, like in the previous class, we have done power of the point, tangent from an external point, normal to a circle, tangent at a point on the circle, its various forms like x1 plus y1 equals to a square, slope form y equals to mx plus minus a under root of 1 plus m square. This is what we have already covered. So now we are here with a chord of contact. Chord of contact is what? If from an external point you draw two tangents to a circle which intersect the circle at A and B, or I should say which meet the circle at A and B, then the line joining this AB. Okay, line joining this AB is called chord of contact. So from any external point, two tangents can be drawn to a given circle. The chord joining point of contact of the two tangents is called chord of contact. Am I clear? So how do I get it? Now if this external point is x1 comma y1, if this external point is x1 comma y1, so equation of AB, which is chord of contact, is, now let us assume the circle is 2gx plus 2fy plus c equals to 0. So equation of chord of contact is x1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. Am I clear? Equation of chord of contact is x1 plus y1 plus g times x plus x1 plus f times y plus y1 plus c equals to 0. So this chord of contact can be obtained by following substitution. Substitution is what? Replace x square by x1. Replace y square by y1. Replace x by x plus x1 by 2. Replace y by y plus y1 by 2 and keep the constant as it is. Am I clear? Now see, you must be thinking like this is exactly the equation of tangent. Yes or no? Yes, it is. But the difference is it will be a tangent if this x1, y1 point is lying on the circle. It will be a tangent if x1, y1 point is lying on the circle, and it will be a chord of contact if x1, y1 point is lying outside the circle. Got it? So it will be a tangent if x1, y1 point is lying in the circle, and it will be a chord of lying on the circle, and it will be a chord of contact if x1, y1 point is lying inside the circle. Am I clear? So this is what I call chord of contact. Got it? Now chord with the given middle point. See, you have to find the equation of this chord whose middle point M is given as x1, y1. This is the center of the circle. Let the circle be x square plus y square plus 2gx plus 2fy plus c equals to 0. Its center is minus g minus f. Got it? So slope of OM is y1 plus f upon x1 plus g. So slope of AB is what? AB is negative of reciprocal of this. So minus of x1 plus g upon y1 plus f. Got it? So equation of chord will be y minus y1 is slope x1 plus g upon y1 plus f into x minus x. Now, if you simplify it, you get equation of chord with the given middle point as t equals to s1. Now, t is what? T is the equation after doing those substitution, this, and S1 is what? Power of the point, put that point into the circle. So T is what? Xx1 plus yy1 plus g times x plus x1 plus f times y plus y1 plus c equals to S1 is what? X1 square plus y1 square plus 2gx1 plus 2f y1 plus c. This c will cancel, and rest of the equation is what? Chord with the given middle point. So this is what you should remember. Am I clear? Like, write down a very popular simple question. Find the equation of tangent from equation of tangent, not this, find equation of chord of contact to the circle 3x minus 1 equals to 0 from a point 5 comma 7 from a point 5 comma 7 to 8. Give it a try quickly. This is a circle. So if there is a point this 5 comma 7, this point said outside the circle, that's very much clear. You place this point in the circle, you get a positive quantity. This is A. And is my voice not audible, guys? Is my voice audible? Tell me once again. Yes, is my voice audible to you? Others also tell me if my voice is audible or not. Okay. So some one student mark, no, it is not audible. So please, I think, recheck your audio settings. And the rest I am quite audible to almost everyone. Okay. So equation of chord of contact will be what? 5x, that is xx1, 7y, that is yy1, x you should replace by x plus x1 by 2, minus 1 equals to 0. That's it. Got it? Now, just multiply it by 2. You get 8 plus 3, 11x plus 14y plus 13 equals to 0. Got it? JNVH, please increase your audio sound. Increase the volume of your system, I think. All right. Now see something very important. Say this is a circle. Hello. Thank you. Actually, power went down. That is why I lost the connection. Well, this is a circle. Say the circle is x square plus y square equals to 25. All right. Now, outside the circle, there is a point minus 8 comma 1. Now, from this minus 8 comma 1, you have drawn two tangents. One this, meeting it at A, and other this, meeting it at B. Now, this AB is drawn. Got it? Tangent is drawn, meeting the circle at A and B, and now AB is connected. So once you connect the AB, what all they can ask you? AB is connected. Now, from this A, if perpendicular is dropped to the tangent, it will pass through the center, and this will also pass through the center. Got it? Is it fine, everybody? So now the first question they can ask you, equation of AB. So that is the chord of contact. So since it is the chord of contact, its equation will be 8x with a negative sign plus y equals to 25. So 8x minus y plus 25 equal to 0. Easy? Now, second question what they can ask you, find the length of tangents. Say this, I call this point P, the center is O, AP. So AP will be what? Root S1 I told you. That is under root of 81 plus 1 minus 25. 82 minus 25 is 57. Got it? So this length is under root of 57. Am I correct? Now, as a third part, what they can ask you, angle between the tangents, angle between the tangents P. Now see, let us assume this angle is theta. Radius of circle is 5. So you know sine theta is going to be 5 upon root 57. Sine theta is going to be 5 upon root 57. Got it? So this is your sine theta. So angle between the tangents is what? 2 theta. 2 the sine inverse 5 upon root 57. Got it? Now, what next they can ask you? Area of triangle. Don't take triangle, take entire quadrilateral PBOA. Area of quadrilateral. Now see, area of this quadrilateral is going to be double of area of triangle POA. So that is 2 times what is the area of triangle POA? Base root 57, height is 57. So it is 5 root 57 upon 2. And then you are going to make double of it. So it is 5 under root of 57. Got it? Now, the last and the most important thing that can be asked here is what? Find the equation of circle of quadrilateral PBOA. Now see, these two are 90 degree, yes or no? That means any circle, if taken OP as diameter, will pass through A and B also. Because angles in the semicircle are 90 degree. So equation of semicircle triangle POAB is equation of circle with diametric ends as minus 8,1 and another is the center of the circle, which I have taken 0, 0 in this case. Got it? So this was all about chord of contact. Now, position of two circles. With respect to each other. Position of two circles with respect to each other. So, position of two circles with respect to each other. Now see, first of all, let's understand two new terms. Transverse common tangent and other is direct common tangent. Now, what is transverse common tangent? One circle is this, other circle is this. So, in case of direct common tangent, both the centers lie on same side of equality. Same side of tangent like this. This is ADCT, direct common tangent. All right. Now there comes a term transverse common tangent, which is a common tangent where both the circles lie on either side of this. Got it? So this kind of tangent we call TCT, transverse common tangent. And that one where both the centers lie on same side of tangent, they are direct common tangent. And when circles lie on opposite side of the line, that line, touching that line is called transverse common tangent. Got it? Now, position of two circles with respect to each other. See, there is a case where both the circles lie distant from each other. Yeah, like this is the center of a circle. This is the center of another circle. So, when both the circles are distant from each other, now what will be the condition? See, if their centers are C1, then C1, C2 is more than R1 plus R2. C1, C2 is more than R1 plus R2. Got it? And there will be four common tangents, out of which two DCT. You can see one here and similarly one here. Okay. So this is what direct common tangent. Similarly, there are two transverse common tangents also, like one of this and other is this. Am I clear? So now this was case one. Case two. When two circles touch each other externally. When two circles touch each other externally. So like one case is this and other case is this. So definitely distance between their centers is sum of the radii. In this case, there will be three common tangents. So two in this case DCT and one will be TCT. Got it? Now case three. When two circles intersect. Now the matter is something like this. One circle is this and other circle is this. Got it? In this case, C1, C2 will be less than R1 plus R2, but it will be more than mod R1 minus R2. See, this is very important. In this case, there will be two common tangents and both direct common tangent. One here and one here. Got it? Case 4. When two circles touch each other internally. Like this is your case. When two circles touch each other internally. Say C1 center is C2 is this. So in this case, C1, C2 is mod R1 minus R2. Got it? And in this case, there will only be one common tangent. Got it? So only one common tangent, that is DCT. Got it? And case 5, when one circle lie inside the other one. like this. One circle is this and other is this. So in this case, what? C1, C2 even less than R1 minus R2. And no contact, no tangent. Got it? So this is how we remember things about the common tangents. All right. So the cases are, first of all, what is transverse common tangent, direct common tangent? When both the circles lie on same side of tangent, they are called direct common tangent. When circles lie on either side of tangent, they are called transverse common tangent. So when two circles touch each other externally, are distant from each other. When two circles are distant from each other, that means there will be total 4 common tangents, 2 direct common tangent, 2 transverse common tangent. In that case, C1, C2 will be greater than R1 plus R2. When two circles touch each other externally, in that case, C1, C2 is R1 plus R2. There will be 3 common tangents, 2 direct, 1 transverse. When two circles intersect at 2 distinct points, there will be only 2 common tangents, both direct. And in that case, C1, C2 is less than R1 plus R2, but more than mod R1 minus R2. When touch each other internally, one circle is this, other circle is this. So this is a tangent. So C1, C2 is what? Mod of R1 minus R2. Only one direct common, only one common tangent. And when the circles are like one lies inside the other one, then there will be no common tangent. And C1, C2, sorry, I made a mistake. C1, C2 will be less than even R1 minus R2 mod. And now you realize in these 5 cases, there are 5 different situations. And every situation is having different number of common tangents starting from 5, 4, 3, 2, 0, like this. Got it? So if somebody asks me like 2 circles are such that they are having exactly 2 common tangents, that means they are intersecting each other at 2 distinct points. Got it? So this is how we do this thing. Now, length of DCT. Length of DCT. One circle is this, other circle is this. This is C1, this is C2. Now see, this is a direct common tangent. Length of direct common tangent means distance between this point and this point. Length of direct common tangent means distance between these 2 points. Okay, let's do one thing. Draw a line parallel to this. Got it? Let us assume this radius is R1 and this radius is R2. So this will also be R2. Now this angle is 90 degree. This is also 90. So this goes to a parallelogram. So this length is also equal to what? C1, C2. Distance between C1, C2. And this length is what? This is R2 minus R1. So if this AB is the length of DCT, So this AB goes what? Under root of C1 C2 whole square minus R1 minus R2 whole square. This is the formula for length of direct common tangent. All right. And similarly, length of transverse common tangent, if you figure out, that will be under root of C1 C2 whole square minus R1 plus R2 whole square. C1 C2 whole square minus R1 plus R2 whole square. Got it? Have a look. Got it? Now, let's do two questions. Let us see this question. Let the mirror image of this circle in the line y equals to x plus 1 be this circle. R is the radius of C2, then they're asking for alpha plus 6r square. Got it? Now, how to do? See, there is a circle. Mirror image of this circle in some line is like this circle. These two circles are identical. Got it? Now see, taking mirror image of a circle in a line means radius is going to be same. Just you have to take the image of the center. So center is 1, comma 3. Now this is the line y equals to x plus 1. So the line is y minus x equals to 1. So first of all, what we have to find? We have to find the equation of this line. Okay, say if it is P, this is Q. So equation of PQ will be x plus y equals to 4. It is passing through 1, comma 3. Find their point of intersection. So you get this point D. So point of intersection will be what? If I add both of them, y will be 5 by 2 and x will be 3 by 2. So this is point D. Now let Q be alpha comma beta. Got it? So alpha plus 1 by 2 is 3 by 2. And beta plus 3 upon 2 is 5 by 2. Because this point of intersection D is going to be, sorry, Q is going to be alpha beta and D is going to be the midpoint of PQ. So alpha is what? 2 and beta is what? 2. So this point is 2, comma 2. Am I clear? This point is 2, comma 2 comma 2, according to me, this is the image. So the image circle is what? Image circle is x square plus y square plus 2gx plus 2fy plus 38 upon 5 is going to be 0. So if center is 2 comma 2, that means the circle is going to be x square plus y square minus 4x minus 4y plus 38 upon 5 equals to 0. Got it? Now radius of both the circles, like radius of this circle and radius of this circle, is going to be identical. What is the radius of the first circle? That is 1 plus 9 minus alpha is radius of another circle, 4 plus 4 minus 38 upon 5. Got it? So it is 10 minus alpha is 2 by 5. So your alpha is what? 10 minus 2 by 5. That is 550 minus 2, 48 upon 5. 48 upon 5. Got it? So this is your alpha. So now everything you know, they're asking for alpha plus 6r square. So alpha plus 6r square. See, radius is easy to find out. Got it? This is basically the radius. 4 plus 4 minus 38 upon 5 is what? 2 by 5. Just a moment. So radius is what I got. So now I got values. Alpha is 48 by 5 plus 6 times. Radius is what? This is r. So r square is 2 by 5. So it is 60 by 5. Answer is going to be 2. Got it? Easy question. Have a look. Got it? Chali. Now let's go. See, there is another question. If one of the diameters of this circle is a chord of this circle, then the value of r square is. All right. One of the diameters of this circle is a chord of this circle. Am I clear? Then the value of r square they are asking. Center of the first circle is 2 root 2 comma 6 root 2. By 2 also the root 2 comma 3 root 2. Clear? Now give it a thought for a moment. Think about it. There is no point if I keep on solving everything. Quickly thought. Now see, for the first circle, this circle, what is the radius? Radius is under root of g square, that is 2, plus f square 18 minus c. Got it? So this is root 6. Got it? Now that means this another circle, and I call this radius as capital R. Now this circle has a chord of length, because this chord is a diameter of the previous circle. That means length of this chord is 2 root 6. Center of this new circle is 2 root 2, comma 2 root 2. This and this. Now this is his radius, capital R. Got it? And now, and since it is the diameter, this center is what? This point is what? Midpoint, that is root 2, comma 3 root 2. So let this distance is b. So capital R square is p square plus root 6 whole square. That is 6 plus under root. P is what? Distance between 2 root 2, comma 2 root 2 and root 2, comma 3 root 2. So that is root 2 square plus root 2 square. So this is equals to 6 plus 4, 10. Have a look. This is what they are asking. And the value of small r square. So this is not capital R basically. This is small r. All right. So this is what they were asking. So the main concept is one of the diameter of this circle. So this diameter, length of the diameter will be the length of chord for the another circle. Length of diameter will be length of chord for the another circle. Am I clear? Got it? Anyways, guys, this would be all for today. Now, if I try to push it any further, it is going to be very difficult, as it is a tough chapter. So make sure you remember these position of two circles with respect to each other. This is what we started with today. And before that, what we have done, equation of chord of contact and equation of chord with a given middle point. Also, if they have given you a circle outside which there is a point, what all can they ask you? And they can ask you angle APB. They can ask you area of this quadrilateral. The most important, they can ask you this area or radius of the circumcircle of quadrilateral OAPB. Got it? And so on and so forth. So that would be all for the day. Thank you so much. Study hard and keep studying. Now, just a small feedback for the class.